CATIA V5. So over here we have the following assembly. You will find the link in the video description. This is from GrabCAD. Now this is currently assembled within assembly design. So we have the various constraints over here. If I will go to manipulate with respects to constraints, I will have the possibility to rotate this roller around the y-axis, as we can see over here. Now, we are going to see how to convert those within DMU Kinematics. Therefore, I will go to Start, over here, Digital Mockup, DMU Kinematics. And we have the following feature over here, Assembly Constraints Conversion. I also have a video regarding this on my channel. I will put the link in the description, and we're going to see that in some cases this will allow the creation of kinematic joints quite good. But for this case study, if I will go with this, I will create a new mechanism. And we're going to have a total of 10 pairs over here. If I will click over here on Auto Create, CATIA will now take a look at all the assembly constraints over here, and we'll try to convert those within joints. So I will click Auto Create. We're going to see that 0 out of 10 for all of those. Therefore, the mechanism has been created. So if I will expand the mechanism over here, we're going to see a degree of freedom of 4 in this case. And regarding the joints, we have various planar joints and cylindrical for this case study. So over here we have the first planar constraint. We're going to have a cylindrical over here. So as we can see, CATIA didn't manage to properly understand the constraints over here. So this should have been a revolve in order to simulate this. Therefore, I will delete all of those joints over here by clicking on delete. We're going to see that this will also delete all the children, which will be the constraints over here. Now, for the fixed part, it is better to create a new subassembly, and all of those fixed elements should be added over there. Because if I will go like this, fixed part for mechanism 1, and I will create on the base that constraint of fixed part, we're going to see that it will be added. But if I will define a new fixed part for mechanism 1, and I will select this fixture on the left, we're going to see that that will be replaced over here. So the base will no longer be a fix over here within the mechanism. We have that underneath the constraint. And in order to fix this, it is recommended to go to Insert, create a new product. And I will position over here the base, which will be fixed. And we're going to have those two fixtures. So I can select both of those using Shift and move them over here. And now we're going to have all of those products over here. You can quickly show and hide those in order to see that all the fixed components will be over here. And now for the mechanism, I will define the new fixed part, and I will choose the product, and all of those 3 elements will become fixed over here. Now regarding the following constraints over here, we're going to create a revolve joint. For the revolve joint, I will use the transmission shaft over here, and I want the axis of this fixture. And I can also define the plane. In this case, I can easily use an offset of 2 millimeters over here, so I don't need to hide and show in order to put this exactly at 0. And I can define this to be an angle driven. You're going to see that as soon as I will select that, the mechanism can now be simulated. So I can go over here within the mechanism, and I have the possibility to control that shaft rotation. Now, for the other components, if I'm going to hide the roller, we're going to have 2 bearings over here. We can easily just add some rigid joints between the bearings and the shaft, and the simulation will work in this case. So the bearing should be rigid to that, and the other bearing over here as well. If I will go and simulate now, we're going to see that the shaft will rotate, and following that, those bearings will rotate as well. And now for the last constraint will be another rigid joint between this, and I can either select one of the bearings or I can select the shaft. Both of those will work. If I will go and simulate this, We're going to see the mechanism, and I have the possibility to move that. If I want to change the limit, I can do that over here. If I want to go way beyond 360 for both the lower value and the high value. And over here I can click insert. I can also animate the viewport so that the camera will rotate while I'm changing this. I will also hit insert, and afterwards I want this to go all the way to 360, and the perspective should be like this. And now if I will jump from start, I will change the interpolation step over here. I want this to go continuous, so the loop mode. If I will click play forward, we're gonna see how this will animate. And we also have that animated viewport, which in this case, we see how that will turn the camera around the 3D model. And at the end, it will start back within that loop. We can also change the loop to be like this. So back and forth, and we see it's already going backwards over here. Okay, so I hope you enjoyed this kind of content. I will position a similar video on the left side and a subscribe button to the right. So that's it. Thanks for watching.